Right, let's take a look at radicals. And my radicals are really kind of just talking about square roots. We want to be able to simplify them, add and subtract, multiply, divide, and estimate. So we kind of have the 5 skills over here. The first thing you want to do is you want to certainly memorize the first 15 perfect squares. We get this list by just squaring the first 15 integers. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and so on. These are the important ones because these are the ones that we can do in our head, meaning these are the ones that you actually can do the square roots of, right? The square root of 100 is 10. Well, why? Well, because 100 is 10 squared. The square root of 25 is 5 because 5 squared is 25. Right? We don't know what the square root of 40 is. We don't know what the square root of 7 is because it's not a perfect square, right? We can't reduce those. The square root of 7 we would just have to leave as the square root of 7. We could estimate it as a decimal, but the square root of 7 is an irrational number, meaning it cannot be expressed as a fraction or even a repeating decimal. Okay, so let's kind of go through just some examples of each of these different things, and we'll start by looking at how we simplify square roots. So we're going to look at the square root of 20 and we're going to simplify it. And what you're going to do, again, assuming you know this list or you have this list out there for you, you're going to think of the biggest perfect square that's a factor of 20. So what times what equals 20? And again, you want the biggest one possible. So like, well, 20 is 2 times 10. And even though that's a true statement, 2 and 10 aren't perfect squares. So don't factor 20 into 2 times 10. Factor into the biggest perfect square. Like, oh, okay, that's just 4 times 5. 4 is the biggest perfect square. But we know the square root of 4. The square root of 4 is 2. And the square root of 5, well, I don't know what the square root of 5 is. It's not a perfect square. So the 5 has to chill out under the radical. Right? So we've simplified the square root of 20. 20 is 4 times 5, and then we can actually take the square root of 4, which is 2. Remember, see how the 2 came outside because we evaluated it, and the square root of 5 chills. 75, all right, well, 75 is 5 times 15. Again, that's not really helpful because 5 and 15 aren't perfect squares. You're like, oh, check it out, 25. I got this. 75 is really just 25 times 3. The square root of 25 is 5, and we don't know the square root of 3, right? It's just an irrational number, so it's just got to chill inside. 500, oh man. Well, 500 is 4 times 125. No, I want the biggest perfect square. Ooh, 100. 100 goes into 500. That's just 100 times 5. Okay, the square root of 100 is 10. And the square root of 5 has to chill. Okay, I think I'm getting the hang of this. 98. That one's tricky. Which one of these? What's the biggest one of those that goes into 98? Ooh, 49. 49 times 2. The square root of 49 is 7, and the square root of 2 has to chill out. All right, we'll do one more. How about the square root of 108? Ooh, 4. 4 goes into 108. 27 times. Ooh, but is 4 the biggest? Ooh, what about 9? 9 goes into 108. It'd be 9 times 12. But is that the biggest? You're like, nope. What about 36? You're like, ooh, 36 is actually the biggest. How about 36 times 3? The square root of 36 is 6, and the square root of 3 has to chill. As long as you take out the biggest one first, you'll always just do 2 steps. Take it, factor it, and then actually take the square root of 4. Take the square root of 25. Take the square root of 100, square root of 49, and the square root of 36. And again, when you take the square root, it pops out of the square root, meaning you actually evaluated the square root, and then you're left with the number. Again, always do the biggest one, and then you can always simplify it in 1 step. And again, obviously, knowing this list was important for me to know the 4 and the 25 and the 100 and the 49 and the 36. Okay, so simplifying radicals. First part of the lesson. Now, let's add and subtract. And again, there's a reason we need to simplify. You're like, oh man, how am I going to add the square root of 8 and the square root of 50. How am I going to add those together? Well, you can't yet. You're going to have to do some work. And so what we want to do is we need to simplify those first. So the square root of 8 is 4 times 2. The square root of 50 is 25 times 2. The square root of 4 is 2, and the 2 has to chill. The square root of 25 is 5, and the 2 has to chill. You're like, oh, wait a second now. 2 radical 2 plus 5 radical 2. Well, that's kind of like saying 2x plus 5x. That'd be 7x. Well, if you have 2 radical 2's and you have another 5 radical 2's, then don't you really just have 7 radical 2's? Hopefully that makes sense. All right, let's keep going. 12, okay, that's 4 and 3. 27 is 9 and 3. The square root of 4 is 2. The square root of 9 is 3. 2 radical 3's plus 3 radical 3's, well, that's 5 radical 3's. So it's very similar to like terms when we like adding x squares and x's. They have to be the same. 2 radical 2's and 5 radical 2's or 7 radical 2's. 2 of those and 3 of those, there's 5 of those. And it wouldn't be any different if we subtracted them. So 200, and that's 100 times 2, 32, that's going to be 16 times 2. The square root of 100 is 10 radical 2's. The square root of 16 is 4 radical 2's. So I have 10 radical 2's and I minus 4 radical 2's, so I am left with 6 radical 2's. Okay, over here, 45 is 9 times 5. 125 is 25 times 5. The square root of 9 is 3. So I get 3 square root of 5 minus the square root of 25 is 5. 3 radical 5's minus 5 radical 5's is going to be negative 2 radical 5's. Just like 3x minus 5x would be negative 2x. Okay? Now, I didn't do an example of this, but I want to let you know, remember, if you did this and these weren't the same, like 2 radical 2's, so let's just do a quick example. If you add like 2 radical 3's plus 5 radical 7's, these don't match. So you couldn't do anything. That would just be done. It'd be no different than if I said, what's 2x plus 5y? Can you add those together? No, right? They're unlike terms. So if these don't match perfectly, you can't add them together. But you remember, in all these cases, these matched. And again, that's why I said need like terms. It's very similar to like terms in algebra. Okay, so that's how you add and subtract them. All right, now how would you multiply them? Well, there's a couple ways, but I'm just going to kind of show you one that we can talk more about in class. But you multiply radicals with radicals and numbers with numbers. So the square root of 5 times the square root of 15 is the square root of 75. But then we can reduce that. Well, 75 is really just 25 times 3. The square root of 25 is 5, and the square root of 3 has to chill. So the square root of 5 times the square root of 15 is 5 radical 3. Again, there's another way to do that, but this way is just fine. Okay, what about if I have numbers out in front? Well, multiply the numbers with the numbers, because really those are all multiplication signs. 2 radical 6 is just 2 times radical 6 times 5 times radical 15. So let's just multiply 2 and 5 together to give us 10, and the 6 and the 15 together to give us the square root of 90. Then let's do the square root of 90 is 9 times 10. And again, this is a multiplication symbol there. That's 10 times this. Okay, so that's 10 times the square root of 9, which is 3. 10 times 3 is 30. And unfortunately, that square root of 10 just has to chill. Nothing else we can do with it. Okay, so the square root of 14, you can think of it as like there's a 1 there. So it's the 3 and the 1, just make a 3. And then we get the square root of 140. Oh, 140. What goes into 140? Well, 2 and 70, and then 4 and 35. Is that really it? I think it is. So that's just 4 times 35 So then 3 times the square root of 4. Well, the square root of 4 is 2. 3 times 2 is 6. And then there's nothing you can do about the square root of 35. It's just 5 times 7. Neither of those are perfect squares, so that's all you can do. Okay, let's come down here. Now we're going to estimate. You're like, oh, square root of 50. Estimate. Oh, really what we mean by estimate, we're going to turn it into a decimal. Now we could just plug it into our calculator, but we should have an idea. The square root of 50 is just a number. Now I know it's an irrational number, but it is just a number. And isn't it just bigger than the square root of 49? And since we know the square root of 49 is 7, and isn't the square root of 50 probably like 7.1? So you get out your calculator and you're like, all right, let's check it out. What is 50 square root? And you get 7.07. So I estimated 7.1. That was really close, right? Very close. All right, square root of 95. All right. Well, it's a little bit less than the square root of 100, because 95 is less than 100. The square root of 100 is 10. So the square root of 95 might be like 9.6. Okay. Square root of 95 is 9.7. All right, so I was off a little bit. I said 9.6, and it's actually 9.75. And again, I'm doing this real. Our square root of 10. Well, square root of 9 is 3, so square root of 10 is a little bit bigger than 3, maybe 3.2. 10 square root, 3.16. Ha, pretty close. Close enough. All right, now these two probably want to know. Memorize, right? They come up enough. Now the square root of 2, we're going to know is 1.41, and this is 1.73. You probably could have guessed somewhere in there, but those just come up enough in math. It's probably just want to memorize the square root of 2 is really close to 1.41, and the square root of 3 is really close to 1.73. Again, you know, the square root of 1 is 1, and the square root of 4 is 2. So you knew they were in there, and so this one's probably a little bit closer to 1, and this one's a little bit closer to 2, but that's what they actually are. Okay, so we've added and subtracted where we need like terms. We can multiply with some examples. Here's how to estimate. And then the most annoying one is dividing. Oh, gross. Dividing, and again, dividing, simplifying, all kind of the same thing. Okay, so what we have to do is we're gonna multiply top and bottom by that radical, right? This sometimes dividing is called rationalizing, to rationalize the denominator. It's really dumb, but it is useful, so we have to do it. Okay, so what we're gonna do is we're gonna multiply top and bottom by the radical. So I have 3 divided by radical 2. What I'm gonna do is I'm gonna multiply top and bottom by radical 2. And what that's gonna accomplish, the top is just gonna be 3 radical 2, and the denominator, think about this, square root of 2 times the square root of 2. Well, if you look at our previous rules, that would be the square root of 4, but the square root of 4 is 2. And you're like, oh, of course, right? The square root of 2 times the square root of 2 has to just be 2. Isn't it true that the square root of anything times itself is just that thing, right? This is really a half power, and this is a half power. Hopefully that makes sense. And if you really wanted to write it out, like, for instance, the square root of 5 times the square root of 5 is just the square root of 25, but the square root of 25 is 5 for the same reason. Okay, so down here is just 2. And can that be simplified at all? And you're like, nope, 3 radical 2 over 2. See how I've gotten rid of the square root in the denominator? That's what this dumb rationalized word means. Okay, so let's go down here. We're gonna multiply top and bottom by the square root of 3. A lot of these are really easy. That's just 5 radical 3 over 3 and nothing you can do. Let's do this one. Top and bottom by radical 5. 20 radical 5 over 5. You're like, ooh, I can simplify this because 20 divided by 5 is 4. So I can go a little further on that one. All right, multiply top and bottom by radical 2. 6 radical 2 over 2, but 6 over 2 is just 3. Okay, multiply top and bottom by radical 3. 12 radical 3 over 3. 12 over 3 is 4, so I can go a little further on that one. This one's just kind of, you know, the same thing. Multiply top and bottom by radical 3. So that's 5 radical 6 over 3, and you can't do anything, right? 5/3 is just 5/3. Okay, so we went through all the different operations you can do with radicals, and I know this video is long, but there's just a lot of different examples that I wanted to show you. So looking back, we need to be able to divide, estimate, multiply, add, subtract, simplify, and again, a lot of it really goes down to you having a good idea of all the perfect squares.